Hello.
Hiya.
Can you see and hear me right?
Yeah.
Excellent. How are you doing?
Good, thank you. How are you?
Yeah, very good, thank you.
Good.
So do you have any particular maths you want to learn?
No, I'm not fussed.
Well, in that case, we'll look at triangles. We'll do triangles to death. So yeah, if we go to our real-time board, and let's go to page 3, I think.
Yeah.
So we want to be able to basically look at triangles and have various bits of information about them and use that to work out other pieces of information. But before we do that, I'm just going to put a few triangles on and we'll talk about what they're called a second. So, or we're going to try, my drawing may let us down somewhat. Whoops. Okay, so those 3 triangles there.
Yeah.
Can you see where I'm going with those? Do you know what any of those are called, or what
Yeah.
any of their features are?
From the left, you've got the equilateral, then you've got an isosceles, and then you've got a right angle.
Okay, perfect. So obviously the right angle's there.
Yeah.
Okay, and we're going to start off with the right angle one. I don't know how up to speed you are with this, so we'll just see how quickly it goes.
Yeah.
So if we had this right angle triangle, so I'm just going to test you, and if you get it, great. If not, we'll talk about it. And let's say this is 35 degrees, and this is 10 centimeters. Do you have any idea how we would work out this length here?
Oh God. Now I can't remember.
Okay. We're going to take one step back then, and we'll do Pythagoras, which says if we have a right angle triangle, this side and this side and this side are related like this. C squared equals A squared plus B squared.
Yeah.
So if, let's say, B equaled 3 and A equaled 4, what would C equal?
7.
No.
Okay. Oh wait, 3 squared and so it would be 3 squared, which is 9, and then 4 squared, which is 16, and then that 25. Yeah.
Yep. So far so good. So are we saying C is 25?
Oh wait, no, it'd be 25 squared, right?
So you're 95% of the way there. I'm going to work it through. So basically we've got C squared equals 4 squared
Yeah.
plus 3 squared. So C squared equals 25.
Yeah.
So C equals, so how do we find C?
Oh, right. The square root, which is 5.
Yeah, perfect. Normally, they don't have such nice numbers as 3, 4 and 5. Normally the last one would be some mean number.
Yeah.
Okay, right, so I'm going to put in some new numbers, and this time you can have a hack at it. Let's say this was 11 and this was 7. See if you can write the formula down, fill in what we know, just like what I did a second ago. Have you got a calculator to hand?
Got my phone. I've got a phone calculator.
Well, that would all come to 170.
170.
Yeah, 7 squared plus 11 squared.
The square root of 170
is 13.0. Okay. This time we're going to know C. C is going to be 100. And we're going to know B. B is going to be 70. But we're not going to know A. So see if you can calculate A.
So it would be yeah. Would it be B squared minus C? No, not minus C. Or would it be C squared minus B squared?
Yeah, it will be that. I don't know why I choose such big numbers. It's going to mean it's going to take longer to type into the calculator. So that's not correct. Because 100 minus 70 would be 30. But 100.
But it's 100 squared. Oh yeah.
Yeah.
Yeah. Thank you.
So if you type in your calculator 100 squared minus 70 squared, you get 5100.
And then the square root of that. I think I can work square root out in the normal calculator generally.
What, on the phone calculator?
No.
On my phone calculator, if you tilt the phone sideways, it then becomes a scientific calculator and has a bit more functionality.
There we go, yeah.
Awesome.
I don't know if I've done this right. 71 point loads of numbers.
Yep, go for 71.4.
Okay. Whoa!
That's artistic.
71.4. There we go. Yep.
Awesome. So what I'm going to encourage you to do when we introduce some of the triangle formulas is the first step is always to write it down in full. So it would be, in this case, c squared equals a squared plus b squared.
Hmm.
And then we would rearrange.
Oh, and then rearrange it, yeah.
Yeah. Because later on, when it's a bit more complicated, we're going to be wanting to do as little thinking as possible. So we just want to write it down, the formula we know, which by then we'll know, and then rearrange it from there. Okay, let's go to try a slightly meaner one. Going to have a triangle where the two lengths are the same. Do you know what triangle that's called, where these two lengths are the same? Oh yeah, we looked at that. Sorry, we already. Yeah, so isosceles triangle.
Yeah.
So this is an isosceles triangle, and this length here is 10.
Mm-hmm.
And my question is, what's this length?
Oh, so wait. So So and those two values are the same.
Yeah.
So
we could call them both x if they're the same. They don't need different names because they're the same.
So squared. It'd be x squared add x squared, wouldn't it?
Yeah. So if we have x squared add x squared, how many x squareds do we have?
Oh, 2x squared.
Yeah. Okay.
Yeah, shall I rearrange the formula so that it's x equals blah, blah, blah?
Yeah.
Okay. 2 minus 2. So x squared. Right?
Yes.
Then need to square root it, don't we? No.
Yeah.
So, um,
So square root of 50, which is 7.07.
okay. So that's what x is.
Yeah.
Oh, okay.
Hmm.
Okay.
So it's quite a fun question because we didn't really have all the information we needed because we needed two known sides and one unknown side,
Yeah.
but we managed to get away without having enough information, or at least deriving the information.
Yeah.
Okay, I'm going to delete all your hard work. So, gonna go in several places. So, I'm going to talk about a function for a second, but the details of a function aren't too important right now, but I just got to talk about functions. So, functions take a number and spit out a new number. And we can invent our own functions. So, and I think I might have mentioned this last week, but we could invent our own function, and it could be this: x squared plus 2. And all it does is it takes x, it squares it, and then it adds on 2. Now the functions we're going to be dealing with are sine, cos and tan from SOA-Katoa. So you have sine of x equals some number. And it takes this function sine, takes in this number, does some mysterious processing, and then chucks out the number.
Yeah.
Now, sometimes with people, we work out this sine function for ourselves, just so people are familiar that it's not a magic thing. It's, it can be derived by mere mortals. However, we're going to skip that, and we're just going to use it. Its purposes, the sine function's purposes, if you have a triangle and you have this angle here, which I've done as theta, it links these two sides together. That's basically its job. So if we call this h for hypotenuse, and we call this one O for opposite, sine theta equals opposite over hypotenuse.
Mm-hmm.
So sine is a function, it takes this angle and it processes it, and its output will be opposite over hypotenuse.
Right.
And we're going to have to be able to rearrange that every which way. For example, to get opposite on its own, we would times both sides by h, and that would give us h sine theta equals opposite. So there's three ways we might want this, we might want the angle, we might want opposite, we might want hypotenuse. So depending on what we want, we're going to have to be able to rearrange it every which way.
Yeah.
So the first thing we're going to do is play around with SOA-Katoa. So we have our memory map of being able to work out the functions. And then we're going to practice rearranging them, and then we're going to apply them to triangles. So hopefully, when we apply them to triangles, the other stuff will be a bit more flowing. So we have this phrase SOA-Katoa. Do you remember how we use this to derive what all the three functions look like?
Well, we've already done the solve, which is sine is opposite over hypotenuse. Then the CAF, which is adjacent over hypotenuse.
And what does the C stand for?
Oh, cos. and then it's tan is opposite over adjacent.
So this first letter tells us the function, C for cos. The second letter tells us what's on top.
Yep.
And the third letter tells us what's underneath. And if we had a triangle, right angle triangle, this angle, and we're dealing with two sides, say we were dealing with this side and this side.
Yep.
How do we work out which of those equations we need?
Well, that's the hypotenuse and the adjacent, so it's cos.
Okay, nice. So that's going to be our first step each time. We're going to be identifying which function we need, and then our second step is we're going to write it out in full. And our third step will be rearrange if necessary. So actually on page 2, I'm going to, as we go through this, I'm going to build up our step-by-step guide. I'm going to get rid of BODMAS from last time. Oops, I'm going to try to. So step 1 is identify correct equation. We're definitely going to spell something wrong and it's going to be solidified in this video forever.
It's fine with doing maths.
Yeah, it's true. If anything, it verifies my ability at maths. Okay, so this is a step we're going to work on in a second, rearrange if necessary. Okay, so back to page 3. See if you can rearrange that to make opposite the subject.
So if I take hypotenuse over to the other side, then right, yeah. So then I might be overcomplicating things here, but
it's kind of a good point. You could, so anyway, that is that's mathematically the correct answer.
okay.
You could write h sine x, but that's
Okay.
only because we know if we put it before, that's effectively times,
Okay.
and we know the x is going into the function. Because when you write h sine x, it looks like h and x are doing about the same thing,
Yeah.
but they're not. X is going into the function, and h is doing exactly what you said with these brackets. H is timesing the whole lot. So for example, if you wrote sine xh, that's a kind of a dangerous thing to write because you don't know what's going in the function.
Yeah.
Is it all going in the function? Or is it only the x is going in the function and then it's been times by h? If you write h at the beginning, like that, then it will work. If you want to write the brackets, if you want to keep the brackets in, that's fine as well.
Okay. Yeah.
So anyway, so we've done one rearrangement and we've got h sine x equals opposite. So this time we're going to try and make h the subject. Hypotenuse.
I can just take the top and put it on the other side, can't I?
As in, put it on the other side on the top.
Yeah.
Yeah.
I'm not really sure how to write that as a thing, but there you go.
Oh yeah. There's no way of really writing that. Yeah, that's right. So you just left a blank instruction as if to say, you know, you get it. Okay, so our second one is opposite over sine x equals h. So the third thing we want to make the subject is the angle. She did not mean to do that.
So x, right? Okay. So, so I might be completely wrong here. But sorry.
That is very close, but not quite.
Oh.
If we need to get rid of a function, we're basically inversing the function.
Yeah.
It will look like that, apart from it will have a little -1 here.
Oh yeah, yeah. I forgot about that one.
Yeah. Otherwise, we're not.
It's not like changing when it goes over.
Yeah. So we have our three ways we can rearrange these. And obviously it's the same for sine, it's the same for tan.
Mm-hmm.
Right, let's get back to it. So on the page 2, we have our 3 instructions so far. And I guess our 4th instruction will be fill in the numbers. And our 5th instruction will be calculate.
Mm-hmm.
That definitely looks like it's spelled wrong. Well, no one will ever know. Do we need SOA-CATOA up, or do you not need those?
I remember the second.
Okay, we'll start without them then. Right, so we're going to do one of my favourite kind of triangles, one that has 3 sides. And that angle there is going to be 22 degrees. This is going to be 11, and this is going to be R. And your mission is to find R.
Okay. So opposite. We've got the opposite and the adjacent, which is tan.
Correct.
So tan. Oh wait. So 11. Yep.
So yeah, that is correct. So on our list of instructions, we'd actually write it out in full, and at the moment, so the way you've done it now is fine. It won't make any difference. But if you imagine we were rearranging it, and imagine that 11 was some nasty number like 11.621. Generally, if you're rearranging, you don't want to be rearranging whole long numbers. It's much easier to rearrange it when it's just the neat little letters.
Yeah.
But like you have to play it by ear. When you're doing it in your own time, you might not want to do all the steps every time. But definitely, like in an exam situation, you'd want to do all the steps. But anyway, so let's carry on with this because it looks like we're going to get R pretty easily.
Wait, so... Okay, so am I writing it as...
And then your next line is now where you filled in those letters. But normally we would write that, what you've just done, and then we'd rearrange.
Oh, and then...
Yeah. Not that it's wrong, it just means you're going to, it's like easier to write when you're rearranging O and A than say 11.624 and having to rewrite that every 5 seconds.
There we go. So we're trying to get R, which is the opposite. So oh. Yep.
Oh.
So then okay.
It's one of the nice things about working on a digital whiteboard, you can undo your anything you want.
Yep.
And will your phone calculator let you type that in?
We'll see. Should be. So 11, 20. Wait, no, apparently it won't. Unless I did 22 times 11. So 4.4.
Yeah.
Okay.
And does that number look about right, looking at that triangle? I know it's obviously a very rough sketch, but is that feasible, 4.44?
Yeah. Well, there you go.
So I feel we totally have the principle of this, but we're just going to do one more just to...
Yeah.
Just because.
Kind of looks like a rocket.
Yeah. Doesn't really look like a triangle. It's the one thing it doesn't look like. Did I want to do that one? I might change my mind. Yeah, we'll stick with that.
Yeah. So it.
Actually, we won't stick with that. Change my mind. But it's the first stage anyway is doing the cos thing. It's fine.
Oh, okay. Oh, yeah. Seven, 3, 1. Adjacent. Yeah. Um. Yep.
What is h? What is the hypotenuse on that triangle?
The 100.
No. So the hypotenuse is the longest one, which is...
Oh, yeah, because the right hand's on that side. Yeah. Yeah, got it. No. So, we want the hypotenuse of. So, yeah. So, H. Right?
Right.
Yeah, I don't think I'm going to be able to type that one into my calculator.
You could just do a divided by cos thingy. That should do it.
100. Oh, cos. 100 divided by. Oh, yeah, 100.75. Right?
Yeah. So it's actually almost, it's really similar to, those two sides are almost the same.
Yeah.
Is that what we'd expect?
By that drawing, yeah.
By that amazing drawing, yeah. Right, okay. I feel right angle triangles are fine. Yeah, so that's that done. So we move on to the non-right angle ones. When we draw a non-right angle triangle, there's a really standard convention for labelling the edges. Now obviously we don't have a hypotenuse anymore. All of the sides are, nothing really distinguishes them. Are you familiar with the labelling that we use on a non-right angle triangle? We call the angles capital letters, and then the opposite sides.
Oh yeah, yeah, the lowercase.
That's right.
I remember now.
And then we have two formulas. One in case we have two angles and two sides, which looks like this. Which basically means you take an angle, you sine it, and you divide it by its opposite side. It doesn't really matter what the naming conventions are. It just means that angle and that side are opposite, and that angle and that side are opposite. And then you have one for if we know if we're dealing with three sides and one angle, which is a squared equals b squared plus c squared minus 4bc cos a. And I'm suddenly questioning if that is the right formula, which is embarrassing for me. I'm going to check that, unless you magically remember if that's correct or not.
No.
This bit, me not knowing the formula, might have to be edited out, because this isn't cool.
Oh, why ever do?
Yeah. Do you know what? It was super close. Other than that 4, so let's talk about the shape of this one. We have this side and this corresponding angle. Everything else is just the other sides. Other side, other side, other side, other side. And these both get written in two ways just to make our life easier. So this one at the top we can also write, we can flip it around, we can flip both sides.
Yeah.
Any idea why that would be useful? Why we bother flipping it that way around?
There we go. I can see it now. No, I don't know.
If we are finding out an angle, say we're finding out this angle here, we can just times both sides by a. So
Okay.
that a would come up to here and be lost from there. Whereas if we were finding a side, it'd be easier just to times both sides by this sine a.
Yeah.
And considering it's the same thing, you might as well write it in the way up that's most useful. This one here, we can also write it as cos A equals b squared minus c squared, b squared plus c squared minus a squared over 2bc. So if we want to find the angle, then it makes sense to start off with this form of it.
Yeah.
So the first little exercise we're going to do is I'm going to put some bits of information on a triangle, and we'll decide which of these formulas would be better. The top one's called the sine rule, and the bottom one's called the cosine rule, or the cos rule, for obvious reasons. So let's say we're dealing with that side, that angle, and that angle. Which rule would we use for that?
The top one.
Yeah, the sine rule.
Yeah.
How comes?
Because we haven't got all three, we've only got two.
Yeah, we're dealing with two angles and two sides. What about if we had that angle, that side, and that side?
Then we'd use the cos, as we've got three either side.
Okay. And we're going to be using the same step-by-step guide that's on page 2, where we identify the correct equation, write it out in full, rearrange if necessary, etc., etc.
Yeah.
And I kind of want to keep, we might have to end up, because you can carry on working down below the page, and I kind of want to keep all of these around for the moment. So, right, let's say then we had 42 degrees, 61 degrees, 10 centimetres, and x centimetres. And we want to find x.
So we would be using the sine rule.
Yeah. Next question. So we're about to write out full original equation. Which way up are we going to write it?
With the lowercase letters on top.
Yeah, perfect.
Shall I write that out?
Yeah.
And then rearrange. Oh, do I need to? Oh no, because that's. Wait. Does it matter which side is labelled A and which side is labelled B?
No, it really
to its angle.
It really doesn't matter as long as the A's and A's are opposite sides and angles, and B's are opposite sides and angles. It doesn't really matter.
So then, A, so, yeah, wait. Yeah, because then sine A goes on to both the top and the bottom, doesn't it? Of B over sine B.
So we're timesing both sides by sine A.
Yeah.
So there's a couple of ways you could write that, but you could just write sine A times, and then write everything that was there before.
Oh, okay. Yeah.
Yeah.
So then,
Yeah, I don't know if I'm being too picky here, but at this point, that little a would be x.
oh yeah. And I'm not too sure.
Shall I just type that into my...
It'll probably be faster.
Okay, any guesses at what the answer is before I press equals?
Something similar to 10.
Yeah, well my diagram's kind of a lie because I've drawn roughly an equilateral triangle with two big different angles. Anyway,
Oh yeah, that's true.
it's 24.3.
Yeah. Cool.
So the next stage would be we would just practice a few more with all of these, but we're running out of time and it feels like you basically get it in terms of following those step-by-step instructions on page 2.
Yeah.
It's all very much similar to what you just did on this one. One little thing to look out for is, well, you have to bear in mind when you're given a random question, it could be a right angle or it could be a non-right angle. So you have to make sure you don't get stuck in the mind frame of whichever type you were doing last.
Yeah.
And just as a point of interest, this here, sorry, let me just get my pen up. This here could have been written like this. You could have, because sine A is times in it, so it's making everything sine A bit bigger. So you could have written it like this. It would do the same job and possibly be a bit neater. You don't have to, but that's making everything b times bigger, and that makes everything sine A times bigger. And the way I've written it achieves the same.
Yeah.
But anyway, yeah, that all feels pretty solid to me. Okay, so we will leave it there.
Okay.
All right, see you next time.
Yep. See ya.
Bye.